Welcome, everybody. Good morning. Today, I'd like to talk about WebRTC on mobile and our little journey using React Native and some unconventional things we did. So as he said, my name is Saúl. I work for 8x8 on Jitsi and other ancillary projects like React Native, WebRTC. Hopefully, I show you something you didn't know today. A quick Jitsi primer for any of you that might not be familiar with it. It's a set of open source projects. It's basically a turnkey WebRTC platform. In a way, you kind of saw it now with Jellyfish, but Jitsi has everything built in so you can use it. You can also take the lower level components and build something on top, but in general, it is something you can just take it as is and run it. Runs on the web, on mobile, pretty much everywhere. You can host it yourself. We make it easy to self-host. We have a hosted service that helps sustain the project. And if you've seen a screenshot here and there, you like them, this is sort of how it looks like when the marketing people give you a cool screenshot. So how does it look like sort of on the inside? Last I kind of checked, our, in a way, architecture on the client side look a little bit like this. So we've got our standard WebRTC APIs at the bottom. We use XMPP for signaling because when all you have is a hammer, everything looks like a nail. And we've got our signaling layer. We call it a low-level library, but if you compare it with other APIs from different vendors, it's actually higher level, called libjitsi. We do all sorts of signaling, handling, stream management, simulcast, handling on the layer suspension and switching. So it's a pretty comprehensive library. It's reasonably beefy, and it is written in JavaScript. And then our front end bolts on top of that, Jitsi, and it's a little bit bigger than the other thing. Why is this sort of relevant to you at this point? Because when we made the decision of going mobile back in 2016, that's roughly where we started. So we had all of that built, that separation was done. However, Jitsi is, it's been in some battles, and it was built with jQuery and other things. We had to migrate to React. That was sort of the guidelines. Let's begin by migrating to React. Then we're going to use React Native for mobile, and we are going to leverage all of that code that we had already written, all the business logic, your middlewares, your reducers, everything would be shared, except we would branch out when it comes to rendering. So we would use React Native components. On mobile, we would use the DOM on the web, and everybody would be sort of happy. That was the plan. This effort started in 2016, and the first public release on the sort of stores, Play Store, Apple Store, was on the first of, somewhere in March 2017. We started out with React Native 0.27. Any React Native people in the house? A few. So if you've been around, that was a while ago. And important as well is that in this journey, there has never been what in a way you would call a real mobile developer around. I'm as close as you can get to one, I guess. In our team, I've been working on this side for the most part. However, I wouldn't consider myself a mobile developer insofar as I've never shipped a native mobile app. However, I've worked on this thing and all of its teeny tiny inner goings for a really long time. Now, if you want to build a mobile app with React Native and you need WebRTC compatibility, we needed to go on a little side quest of, yes, there was a React Native WebRTC library, but no, it was not in a shape that we could consume it directly. So we started contributing to the project. Eventually, we became the maintainers of it. Then we tried to build a little community around it. So now we've got the React Native WebRTC GitHub org with a number of plugins that add functionality. And in general, if you want to build a WebRTC capable application with React Native, this should probably be the plugin that you want to use. I gave a presentation at Dance Conference ComCom earlier this year. You're welcome to check out that talk. It goes deeper into how we build React Native WebRTC. Today, we're going to use it and build on top of it and see how our mobile app turned out. So, a beautiful diagram here. When we designed our SDK, we modeled it after the SDK we have for web. And it's also somewhat unconventional, even though we've seen more people in the industry take the same approach. Our approach is to be like full frame SDKs as a high level option. So all that green stuff, that's what you get, the full view, that's your SDK. On the web, we do that with an iframe. And we have an API to control everything inside, and you can change things in the UI and layout. However, what you get out of the box is this thing you can plug into your existing app, and it now has like certain meeting capability. Why do we do this? So in general, what our experience has shown is that when people want to add a certain meeting capability to their applications, what they care the most about is their own business, their own whatever it is that they really do. Imagine this is some kind of telehealth organization. Imagine this is, some lawyers, some psychologists. What they care is their practice, their customers. The meeting is just a means to an end. So they don't want to spend, I don't know how many man-hours in building a meetings application. They want to focus on their thing. So that's why we give them this frame you can plug in, customize, make it sort of branded so it matches your app, and then you can focus on growing your business and the other things that are more important to you. And I hear the younger generation call this low code or something like that, but kind of this is where we started because we had all the background in doing exactly the same thing successfully on the web side of the things. We still have like Live Jitsi Meet for those who want to go in the lower level and build their own user interface. But in general, what we've seen in running this as a service is that customers will prefer the full frame option in general. So our first target was to build a native iOS and Android SDKs because we used to be part of Atlassian, now 8x8 for a few years now, and the corporate mobile apps were native, and they wanted to integrate with us that way. Now remember, we had built a React Native app, so we needed to take that into an SDK. So kind of inspired in a way by, for instance, the Google Maps and the YouTube SDKs, which have a similar full frame style or partial frame API. That's what we set out to build. In iOS, it's actually relatively straightforward. In general, you would have one target for your application, which is everything. Now we would add another target, which is our SDK, a framework target, and we would put all the React Native bits in there. Then our app would depend on the SDK, and that's kind of it. A UI view, that's the Jitsi Meet view, would be the API that we give you. You could build a simple controller around it and then present it when you want, and that would be it. Then there is a singleton for wiring app with, for instance, everything your activity delegate, like, when a URL was being opened because you're navigating through a calendar link or something like that, deep linking. In order to integrate easily, we added a little wrapper so that you could plug it in your app delegate. You don't really need to focus on the code that I'm going to show, just listen to me. This is just the concepts that we needed to do to sort of get there. So I said, first, we want to take all the logic related to integrating React Native and put it into our framework target. An interesting thing we have done later is that we have a lightweight SDK, that removes some of the fattest dependencies we have. And that's why we need to get a bit creative there with some manual linking. But in general, just putting all the things React Native related into your framework target would suffice. This is part of our Jitsi Meet view. And in general, the way it would work is you have your React Native bridge that takes care of all the communication between the views and the React Native engine, if you will. And you have a root view that's the only sub-view of our Jitsi Meet view. So all you get is one view fully covered with the React Native stuff. This is a sample of like the type of things you would want to do in the singleton. We would have like a reference to the bridge that controls the React Native engine. And this would be, for instance, the delegate method for handling, when you open a URL, what do you want to do with it? Since we have like Dropbox integration, might be a Dropbox link. Then we try, is it the Google sign-in link? No. Is it the link for our SDK then? We handle it. So this is how we, with a little bit of this code, how we sort of took the React Native part and turned it into a native SDK that was using, anecdotally, React Native on the inside. The result on iOS is that the SDK is sort of hidden because the resulting framework is actually statically linked and everything is inside, and we only depend on 2 other frameworks that we link with, one of them being WebRTC, for example, because it doesn't support static linking. So it's a pretty self-contained thing you can just consume. Now let's look at my least favorite platform, Android. Of course, a lot more complex because it wouldn't be Android otherwise. So you begin by, okay, we have an application, so now we need to build a library target. Now, at the time, I know things have changed a little, but remember, we started with React Native 0.27. There was this Gradle config that was targeting apps, so it wouldn't work it was targeting applications, not libraries. So we had to get a bit creative, and we have to do manual linking, at least for now, which is, we don't change dependencies so often, but it is something. And all this logic to glue up all the React stuff, like bundling the JavaScript and moving things around into your SDK, like all the sounds and assets, was handled by a React Gradle plugin that did not work at all for libraries. It was only focused on apps. You can actually tell by looking at the Android code that they really didn't have this use case in mind, but that has never stopped us, has it? So we went for it. Then, obviously, all your Java dependencies, they need to be somewhere, and because of, well, how Android works, you will end up having a lot of libraries you depend on, and you need to also ship them. So we basically republish or publish all those libraries with like custom, like -Jitsi and a version number, so we can have the whole chain of dependencies on our Maven repo, and you don't need to worry about having them hosted elsewhere and problems like so. The Android Gradle plugin has also been a pain in the rear. Often, like every time we had to update it, we needed to manually go and change how on earth all these merged assets in the APK end up so that the SDK wouldn't miss like the sound files or the picture files or the JavaScript bundle. So it was a fun sort of road. This is how your library target would look like, as I said, because we have manual linking and we want to skip out some dependencies. You end up with a maze of them. In our case, this is a little bit of how our shenanigans for managing all the dependencies and adding them to our SDK with a custom version number, so that we can have the full chain of dependencies that we have controlled, and every SDK has all the dependencies that we depend on republished in the same Maven repo with a version that we control. This is the part that we do here. We also need to publish them, and this is kind of how we handle that. But there is more. Android is always interesting. There's some troublesome, and again, going back to how React Native really catered for apps, there is this React application that your app needs to implement. An SDK cannot ask an Android app, please, can you modify your application implementation to inherit from React application, please and thank you. Not going to happen. And that is a problem with certain dependencies. And maybe some of you are familiar with React Native Reanimated, built by the great folks here at Software Mention. Thankfully, this was fixed at one point in time, but I remember people like us in the community that were building brownfield apps running into this problem where your application does not inherit from React application. So finding specifically the React Native Instance Manager was interesting. Also on Android, just a view is not enough because you need to wire it to like the activity. You need a lot of lifecycle hooks to, for instance, get the permissions and stuff, handle linking. So we ended up settling on a high-level API, which is an activity, and a lower-level API, which is a view, in case you want to do the wiring, plus some auxiliary classes so that you can glue the two together. The way it looks like a little bit is, so first of all, we have our little thing to hold on to the React Native Instance Manager. because we don't have React application. We then have our Jitsi meet activity, which gets like a very simple static launch method, gets a lot of options, and it launches, does its thing. The idea with this API is you're in your app doing, I don't know what, launch a meeting, Jitsi takes over, finish your meeting, Jitsi goes away. And if you want to go a bit the lower level, this would be our view, which is just a simple frame layout. And as you can see right here, we basically have a single subview, which is the React Native root view. In that regard, it's very similar to iOS. So the result is that it's virtually the same as in iOS, but because of how Android dependencies work, everything is like a flat kind of dependency tree in the end. The use of React Native is not hidden in a way, so there is a chance for collisions to some extent. It's rare, but it can happen, and I have heard from some people that, for instance, they want to use our SDK for meetings and some other SDK that uses WebRTC for like calling. And that means that you need to sort of agree on what version of WebRTC you're using under the hood, or it's going to be a little problem. So at this point, achievement unlocked. We got native mobile SDKs. The teams that were using them have been doing so since 2017, somewhere mid-2017. Since I'm here, I'd like to take a chance to thank the good folks here at Software Mansion for building some cool libraries that I've been using for many years now, like the gesture handler, SVG, and the screens, since we introduced navigation. So we wouldn't have done it without you. It's been really great to use. Thank you. Now, things moved since, and a new player entered the game, this Flutter thing, with a weird programming language to go with. And the community had already created some Flutter packages, but eventually became unmaintained, and we got customers and users in our community wanted to use Flutter for some reason, so we ended up making our own, and we built our own Flutter plugin by wrapping our native SDKs. So at this point, you can see this is kind of an onion kind of situation. We got the Flutter layer, the native layer hiding the React Native layer. Works beautifully. And if anybody familiar with Flutter in the house? Not me, so I won't lie. All right. So in Flutter, this is how our API looks like, by the way. It's kind of imperative. So when you say, hey, join a meeting, like a new view controller or a new activity takes over, does its thing, and then it's dismissed. Flutter has this idea of platform views, so you can do like a component that you could put in the middle of the screen, but that doesn't work very well for Android because it needs to latch itself to the activity lifecycle stuff. So we decided that for now, we're not going to do platform views and kind of wait and see. Since Flutter is not our mother tongue, we're waiting to see if, how much interest there is and if we want to venture there. But then, of course, we got to circle back. So people were interested in consuming our SDK directly in another React Native app instead of a native or Flutter app. So, okay, let's go ahead and export our component, the whole thing as a component you can consume. How hard can it be, right? Well, the problem is that when you have like 100+ dependencies, like your SDK is fat as fuck. So it was rough handling the building side of things and all the dependencies. I'm not sure anybody here has had the trouble of dealing with like peer dependencies plus automatic linking. It does not work. So we needed to be a bit creative and add a post-installer script that would tell you what to do. Otherwise, you wouldn't be able to get linking working. And we were lucky enough to get help from Philip Raimus, a Google Summer of Code student last year. And we got almost all the way to the finish line. And then with a little bit of elbow grease, we got there. And now, you have a Jitsi meeting component, pass in some flags, some options, and, Bob's your uncle. So you get what you would expect, which is a component you can put anywhere. This is not a whole thing that takes over. You could put it anywhere in your view hierarchy. but it was a lot more complex than we thought, going sort of back to where we started with just with React Native. So I said we've been building these ones for a while, so you can actually go and check the source code or consume them right now. We publish the Android builds in our own Maven repo, iOS in CocoaPods, which is kind of where people expect it. Flutter has its own marketplace thingamajig. And React Native, of course, NPM. You can find source code for all of these things in our Jitsi org, and there's more information about all the SDKs we have, also for web stuff like Electron and Pure React and the iframe, everything in our SDKs category in the handbook. And honestly, as I was writing this talk, I was thinking, I'm not sure if there is any other way that we could have approached this problem and kind of get where we got supporting all these platforms in a simpler way. Maybe it's me rationalizing what we already did, but so I thought, talk a bit about maintenance. The team of people that work mainly on mobile is 2, if you sort of round it up. And that's not a lot, which means we try to optimize for all these sharing so that people that are not necessarily working on mobile can also contribute to this. We encourage every engineer in the team to work also on the mobile side of things. And then there's people like me that with time have, had to pop open the hood and look what's in it to do the gluing bits with system APIs and whatnot. But in general, people can contribute at the higher layers. So because we're a small team, we try to automate as much as we can of all this SDK releasing process, because we don't want to be busy making fat releases. We just want to push a button and things will happen. So between Jenkins and GitHub Actions, we have automated releasing all of these things. And so far, it has gone pretty well. We don't feel like really adding more platforms is a burden, but we're mindful about this. So we are trying to only tackle and only maintain things we can afford time-wise. But for instance, Flutter doesn't really add a lot of maintenance cost, because the API we offer is a full frame. So then it's a bit of glue code in Kotlin and Swift, and that's kind of where it's at. So the ever interesting question, so what framework do I use for my next mobile app? I hear Pure Native, React Native, Flutter. What do we do? Well, I'm not going to tell you. So I have more questions for anyone asking this. So I think that while it depends on where you are and where you need to be, do you already have a fully blown web application written in something you can share with on mobile? Because if your app is written in Vue.js, I don't know how the Vue.js ecosystem looks like on mobile. Can you bridge that gap easily? Do you have access to a lot of plugins and system libraries? Specifically, if we're talking an RTC-related product, do you have a mature WebRTC plugin? These are the kind of questions you need to ask yourself. What team do you have to build this? Do you have mobile specialists? Then maybe you got to go full native. If you don't, and you want to be able to, basically everybody is a janitor. You just work on whatever you need to work on. Then maybe you can use something which is a bit more abstracted from the system, but then someone will eventually go deep and nail it down. And is sharing the code important to you? It might not sound super important in the beginning, but as I showed early in the presentation, like all the signaling, media handling, simulcasting, dealing with statistics so you can measure quality and everything, like that's a lot of code. And ideally, you don't want to write that multiple times. And if you have written it in something you can share across all the platforms, it might be interesting. And I think it was Jeff Atwood that said that, if something can be written in JavaScript, it will. So if you already have it in JavaScript, maybe the React Native way and this crazy way to do things is something you can leverage. That's all I had for you today. That's where you can find me. And if you have some questions, I believe we have a little bit of time.
Thank you, Saúl. Any questions? Oh, yeah, one. Paulina?
Second. Hey, Saul. Thank you for the talk. At a high level, can you talk about what were the reasons originally to build the mobile app as opposed to using a web view or as opposed to using just the browser app on mobile? And then are there also limitations once you wanted to embed it into an existing native app?
That is a great question. I should have covered that for the next time. So, why not use a browser? So the reality is that even though browsers have grown a lot on mobile, and much to our own reluctance, we have finally enabled, like a few years ago, that you can actually use Jitsi on the mobile browser already. So, but it's not ideal. So you're lacking critical platform integration features. You don't have deep linking, so you can't just pick a link and go straight to a given part of your app. You don't have, for example, in iOS, you don't have call kit integration. So integrating with a system calling mechanism is something pretty important if you're doing a calling app. That's also virtually the only way to keep your app alive if you're doing a calling thing. When you go into the background, browsers will stop timers and your web app will start to be frozen. So some audio will keep going, and then eventually fade out. In fact, one of our customers for Jazz is the Brave browser. And they have an integration. They have Brave Talk, is their product that uses Jitsi. And on the iOS application, they used to just run it in the browser. And since a few versions, they integrated the SDK. So whenever you go to Brave Talk, you actually open the SDK on top of the browser and do this dance that we've talked about with show the view, then vanish the view. And that has resolved all the problems they had with audio issues and what have you. Device management is a lot easier. Well, not easier, but you have a lot more control over when you are on a native app, really. For example, on Android, on Android 12, Bluetooth devices don't show up in media devices.enumerate devices. Why? Because. So we have our own little audio device management module. We decide what type, you cannot decide on any browser API what type of audio you're playing. Is this calling audio? Is this like, a music thing? So they tune the microphones differently. You don't have control over any of this. You don't have proximity APIs. So if you take your phone to your ear, the screen will not dim, so you will be pressing shit with your ear. You don't have control over any of this. And one more important thing you don't have control over is WebRTC itself. When you ship an app, you know exactly what version ships, what codecs it ships with, and what bugs and features it has. If you're using the browser, you're at the mercy of whatever Chrome or Apple, well, Google or Apple do, and sometimes they mess it up, and you don't have the flexibility to do anything about it. So that's why we went native.
Well, thank you.